All right. The next thing we have to consider in this particular topic is angles on intersecting lines. Angles on intersecting lines. We have, if you have two lines that crosses each other, we say they are intersecting lines. All right. All right. So they intersect. This point is point of intersection. So whenever you see this, though the lines are straight line or whatever, yeah, higher percentage of the time, I mean, the lines are always straight, yeah, always straight lines. So you have AB and line CD. Okay. So if you have an angle here and you have another angle there, here you have an angle here, have another angle here. Now, the theorem says that vertically opposite angles, vertically opposite angles are equal. Vertically opposite angles are equal. Remember, the line are all straight line and the line intersect. Yeah, intersect. When they are all straight line and they intersect, the vertically opposite angles are equal. So in that case, we have that the x and y are equal, and as well as a and b. X equals to y and a equals to b. But also remember, don't always forget this. Don't forget this, that they are all straight line. Because they are all straight line, we can also apply that principle here, that the sum of angles on a straight line is 180, meaning that these two angles, x and b, that are on the straight line, will be added up to what? To 180. Or a and x are also on the straight line CD, so they added to 180. And then a and y that are on the straight line AB, so they add to 180. And y and b that are on the straight line CD, they add up to 180. Don't forget that. Don't forget that. So you don't have to forget that. You have to keep that. So you see that as we are learning this, as you are moving, you are trying to, you will see that one problem will lead you to applying a lot of principle, a lot of theorem, yeah, a lot of theorem. So like this one question, if you are given any of the angle, you ask to find others. It does not mean that you must use this particular theorem, vertically opposite angles are equal. No, you have to look at the question, which theorem will solve first? Or after I might have applied this one, which theorem can work next? So you look for what works, not what you think should work, because it is this. All right. So let's go to the next one. So notice you can also have parallel lines. Parallel lines. You see, this is what this you always see something like this. This is trying to show you that these lines are what? Parallel lines. And then if we have another line intersecting both lines. All right, another line intersecting both lines. This will happen if you have here A, B, C, and D, and here you have E, F, G, and H. Note this. First of all, you must identify the parallel lines. All right, you must identify the parallel lines. Or you must also check if the lines are parallels, these two lines, if they are parallels. If these lines are parallels. If they are not parallels, whatever rules I'm going to tell you here will not work. So that will work with other principle. So these particular rules are only working, or will only work, will only work if these two lines are parallel. Right? If these two lines are parallel, the line that intersect both lines. You see now it intersect this other line, also intersect this other line. All right, there is an intersection. There is the line cuts through the both lines. So since it cut through the both lines, this line is called a transversal. 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 It cuts this one and this one. Now, the first theorem you already know, vertically opposite. A equals to B. You can see that. This is vertically opposite, vertically opposite, vertically opposite, vertically opposite. You look up there, vertically opposite, vertically opposite, vertically opposite, vertically opposite. What again? I think that's all. Those are all vertically opposite. E equals to H, um, C equals to B, F equals to G, E equals to H are our vertically opposite angles. Vertically opposite angles. Remember we said vertically opposite angles are equal. 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 Don't forget that. Don't forget that. Vertically opposite angles are equal. So what next? The next is, if you look at the line, since they are parallel, there are angles that are called corresponding angles. All right. That is, when you look at the line, you identify, if you try to identify the position, all right, where the angle is in one line, compare it to another position in this other line, we see such angles which occupy the same position are what? Corresponding angle. Right? They occupy the same position, right? Yeah, A occupy this place. Now, when you try to also look at this line, let me label it line AB or line CD. The same position, line all right, occupy in, sorry, angle A occupy on line AB is the same that angle E occupy on line CD. So we say that A and E are equal. What do we say here? We say corresponding angle, are equal. They are corresponding angle. What happened? This is corresponding, this is corresponding, this is corresponding, and this is corresponding. You can see that C and G are corresponding, D and H are corresponding, B and F are corresponding. So we say corresponding angles are equal. All right. So we move to the next. We move to the next. Corresponding angles are equal. Then you have taken down this, so we'll go to the next one. Now the next is the interior angle. The sum of the interior angle, all right, this is interior, is 180. Sum of interior angles is 180. All right, the sum of interior angles is 180. The same thing, C plus E equals 180. The interior angle is 180. Remember, this only works if these two lines are parallel. You must check that before you consider applying these rules. So what next? Now the next one is alternate angle. I think I love using this for my students to recognize alternate angle. You look at Z, look at it this way. When you see these angles are alternate, this is what we call alternate angle. So if you look at this, you see that these are alternate, All right. So we said that C equals F. We say alternate angles are equal. Alternate alternate angles are equal. T equals to E. And also remember, angle on the straight line is 180. So A and B. So E and F are on the straight line. AB on the straight line, CD on the straight line, CA on the straight line, D and B on the straight line. Sorry, G and E on the straight line, H and F are on a straight line. G and H on the straight line, E and F are on the straight line. So you must also, in fact, as you are learning, you are not learning to forget any theorem. You are not learning to forget anything. As we are moving, you are adding to what you know already. Yeah, you are just adding to what you know. Okay. So I think let's attempt some question.